Hey guys, what's up? It's Brian from Cross Coast Gaming with our Java tutorial, and the last time we made this. We kept the window open, drew a line on the screen, and this time we're going to make, instead of just a line, we're going to make a quad, or a rectangle, or a square. And once we learn this, that's pretty much all we're going to use for our game, because you can overlap textures onto the quads. So for our tile-based game, we can draw the entire map and the enemies and the towers. It's all based on squares. So you can see this time, or last time when we made a line, it had a very simple order of operations. We said we're going to begin drawing the line. We gave it the vertex for the starting point, which was 10, 10, and the vertex for the ending point, which is 100, 100, and then we ended the line. So I whipped up a little grid here, and this might be kind of a review for some of you, but just bear with me here. Nice little refresher. So this is our screen, this grid. I'm not sure if you can see me selecting, but this whole grid is our screen. And for the purpose of this tutorial, I just made it a little 9x9 in here so we can count the indices here. And so something that's different about our screen that is different from most graphs you might see is that the bottom left isn't 0, 0. It's 0, 9, or 0 and the height of our screen. 0, 0 starts at the top left of the screen. Okay? So when y increases, it's going down. So that's something that's kind of not very familiar to just algebra and stuff. It's more a programming and game programming thing. So when y increases, we're actually bringing y down towards the lower end of the screen. So now that we have that taken care of, I'm going to get rid of this little arrow I drew there. And I put a little example square. So if you remember in our program, we had to set each vertex. So for a line, it's only two vertexes, the beginning point and the ending point. And so we said the start is going to be at 10, 10, 10x over, and then 10y down. And the end is going to be 100x over and 100y down. And you kind of see that here. So 10 pixels over, 10 pixels down, 100 pixels over, 100 pixels down. For the square, you have to label every angle. What am I trying to say? Every vertex. There we go. And it does it kind of in an unusual way, at least to me. It goes clockwise. So it starts at the top left, then goes to the top right, and then bottom left. So I made a little example square in here, and we're going to figure out the coordinates for it. So the first thing you do, you see in the top right here, we start with the x, and then we put the y after it. So for this square, it looks like it is at 3x, and then down 3y. Then the top right corner is over 4x, down 3y. The bottom right is over 4x, down 4y. And the bottom left is over 3x down 4y. Okay? Makes sense. I'm looking at it. Yeah, it makes sense. So this is also the same if you wanted to make, say, a rectangle instead of just a square. So let's say we had a rectangle over here. The top left is going to be over 7x and down 2y, so 7, 2. Top right is going to be over 8, down 2. Bottom right is going to be over 8, down 5. And the bottom left is going to be over 7, down 5. So that's how coordinate systems work. If you guys need to pause it and double check what we just did, I think I got it all right. So we're going to go back to our program now and begin this. And so the way we begin this is just like the lines. We say GL begin, GL quads. And then we're going to give it a vertex for the top left. So for this, we'll start at where our line ends. That's going to be 100, 100. And the top right, we'll make it a 50 by 50 square. So over 150, down 100. Over 150, down 150. And over 100, down 150, and then GL end. And let's try running that. Alright, there you go. So you can see it starts right where our line ends, and it's 50 by 50 long. You can tell it's about half the length of the line. So a way that we can make this easier is instead of specifying the bottom right and the top right at the exact coordinate, or the exact pixel coordinate, we can just say we want everything to be relative to this top left starting point, plus the width or plus the height of the square. So we can do that right up here. Just set 2 variables for width and height to 50. Down here, let me add some comments. So bottom right corner and bottom left corner. So the top left is where we're starting our square. So that's going to be our constant point, 100, 100. The top right is going to be 100, 100, but it's going to be plus the width. So 100 plus the width of our square is the x coordinate. Okay. Here is also going to be 100 plus the width of our square, and then 100 plus the height of our square. And then down here is going to be 100, and then 100 plus the height of our square. Okay, and you can see that worked. And then there's one more thing we could do to abstract it even more, and that's make the position. So float x and y equals 100. And let's go down to where we draw it. And we're going to start the square at its x and y position. The width is going to be, or the x coordinate is going to be the x plus the width. The y coordinate is just the y. This is x plus the width, and this is y plus the height. This is the x coordinate, and this is y plus the height. Sorry if I'm going a little fast, but you guys can review this code, and I'm very confident that once you look through it, it'll make sense. So let's play it, and you can see it worked. So we've completely abstracted numbers out of it. So we've just set the values up here for the width and height in the x and y position of the square at the top left corner, and then down here we drew it using those values. So thanks a lot for watching, and I'll see you guys next time.